Quasilinear utility. In economics and consumer theory, quasilinear utility functions are linear in one argument, generally the numeraire. Quasilinear preferences can be represented by the utility function u, x1, x2, xn, equals x1 plus theta, x2, xn backslash display style ux sub 1, x sub 2, backslash lt dots, x sub n equals x sub 1 plus backslash theta, x sub 2, backslash lt dots, x sub n, where theta, backslash display style backslash theta, is strictly concave. 164 A nice property of the quasilinear utility function is that, the Marshallian/Walrasian demand for x2, xn, backslash display style x sub 2, backslash lt dots, x sub n, does not depend on wealth and therefore is not subject to a wealth effect. 165 to 166 The absence of a wealth effect simplifies analysis. 222 and makes quasilinear utility functions a common choice for modeling. Furthermore, when utility is quasilinear, compensating variation, CV, equivalent variation, EV, and consumer surplus are algebraically equivalent. 163 In mechanism design, quasilinear utility ensures that agents can compensate each other with side payments. Definition in terms of preferences. A preference relation, display style sucsim, is quasilinear with respect to commodity 1, called, in this case, the numeraire commodity, if. In other words, a preference relation is quasilinear if there is one commodity, called the numeraire, which shifts the indifference curves outward as consumption of it increases, without changing their slope. In two-dimensional case, the indifference curves are parallel, which is useful because the entire utility function can be determined from a single indifference curve. Definition in terms of utility functions. A utility function is quasilinear in commodity 1 if it is in the form where theta, display style theta, is an arbitrary function. In the case of two goods this function could be, for example, u, x, y, equals x plus y. Display style u left x, y right equals x plus sqrt, y. The quasilinear form is special in that the demand functions for all but one of the consumption goods depend only on the prices and not on the income. E.g., with two commodities with prices x equals 1 and pi, if. Then, maximizing utility subject to the constraint that the demands for the two goods sum to a given income level, the demand for y is derived from the equation. So, which is independent of the income I? The indirect utility function in this case is, which is a special case of the Gorman polar form. 154, 169. Equivalence of definitions. The cardinal and ordinal definitions are equivalent in the case of a convex consumption set with continuous preferences that are locally non-satiated in the first argument.